we are going to solve a hypothesis test example. Citiprop Real Estate Agency advertised that their mean selling time of residential homes is 42 days or less. A competing agency claims that the Citiprop has a mean selling time of greater than 42 days. We are going to test the competing agency's claim at 5% level of significance. So the alpha is 0.05 here. It is assumed that the standard deviation of the selling time of residential homes is 12 days. Actually, this is the standard deviation of the population. So these 12 days is nothing but the standard deviation of the population, so we denote it by sigma. In order to test the competing agency's claim, we pick a sample of 36 recently sold homes and calculate the mean selling time of that, which is 46 days. So the sample size here is 36 and the mean value of the sample is 46 days. So here we wish to provide evidence from the sample data that mu is greater than 42. So we want to reject the Citiprop claim if the x bar, if this 46 days is sufficiently larger than 42 days. So the thing that we want to prove is mu less than 42. So this is the alternative hypothesis. So we can define the null and alternative hypothesis, which is the first step. Mu greater than 42 days. Mu less than equal to 42 days is the alternative hypothesis. Now we have to see whether we have a one-tail or two-tail test. In order to check that, we have a look at the value here, mu greater than 42, this inequality. And this tells us that the rejection area in this question is the upper tail. If x bar is sufficiently larger than 42, we reject H0. So this is the rejection area. And actually, this area, this probability is 0.05. It is the significant level. Now let's continue to solve this question. So here we have one-tailed test. The second step is checking whether sigma is known or unknown to decide which distribution is useful. Here sigma is known, we have it here, so we use Z, normal distribution. So here the test statistic is the Z calculated, x bar minus mu 0 over sigma over square root of n. This is normally distributed. It is normally distributed, because n, the sample size, is large enough. So by the central limit theorem, x bar minus mu 0 with sigma over square root of n is normally distributed. Now we can find the z calculated by substituting the values. X bar is 46 days, mu 0 is 42, sigma is 12, and the sample size is 36. We calculate it and see that the answer is 2. Now we have to check whether the z calculated is in the rejection area or it is not. In order to check that, we have to find the z value here to compare the z calculated with this value, which is called the z critical. So now we have to calculate the z critical here. How do we calculate it? Actually, it is the z that the probability of z greater than z critical is alpha, which is here 0.05. Then you have a look at the main body of data in the normal distribution table to find the closest probability to 0.05, and then you see that the z critical is 1.645, right? So z critical is 1.645. Let's see what the z calculated is. It is 2. Okay, so the z calculated is here, right? It is in the rejection area. So the fourth step is the decision. Here we reject H0 since the z calculated, which is 2, is greater than 1.645, the z critical. It is in the rejection area. And at the end, we can conclude that we reject H0 at 5% level of significance, and it means that the sample does provide enough evidence against H0. It means that the CT probe has a mean selling time that is significantly greater than 42 days. So since the z calculated is in the rejection area, we reject the null hypothesis. Thanks for watching this video.